Okay, we're starting.
Okay.
So today we'll take some time to review. So I'm just gonna, I've posted the review and the key and like a test description and all that jazz. So like you have all that and you've had it for a while. So the plan today is just to kind of take individual questions about stuff. It can be super specific or it can be kind of general. I'll do my best to answer things as neatly and as thoroughly as I can. Lexi? Is that going to be more productive for you guys?
Maybe do like a few from each. Maybe like, yeah, one from each. Well, maybe like.
Okay. So I'm happy to do whatever you guys need me to. So if you guys want to see some stuff first and then do some work after, that's fine. You just tell me what you want me to do and I'll be happy to do it. Okay? So I'll wait. Just whenever you're ready. 1A. Okay. So for this section, the key thing to remember is the range for each of these values, or for each of these functions. So for sine inverse, the range is negative pi over 2 to positive pi over 2. For cosine inverse, the range is 0 to pi. And for tan inverse, the range is negative pi over 2 to positive pi over 2, but not including those end values. Okay. So on number 1A, what I'm going to do is I'm going to go to my unit circle, and I'm going to locate the place where the y coordinate, because it's sine, is 1/2. So if I look at my unit circle, I see that that happens at pi over 6 and 5 pi over 6. Everybody okay there? Yeah, I'm not done with this. If you want to hold for just 1 second, and I'd be happy to come back at you with your question. Is that okay, Kendall?
Yeah.
Okay. Now, are both of these answers? No. Why not? This one is not a solution. The reason is that this is not in the range negative pi over 2 to positive pi over 2. In fact, even if you found something coterminal to it, you can't put it inside of that range. Our only answer here is pi over 6. Kendall, you had a question. This information, if you look at your review and you look at the unit circle on the last page of the review, I believe that I have that information down at the bottom. Is that the case? So that's the same unit circle you're going to get on the test. So you'll have that there for you. Okay? You're welcome. Should we do another one of these? For F. That's in general. That applies to every problem on number 1. Sam?
So like the arc part of arc sine, that just tells you where it has to be.
It's just the same thing as sine inverse. So arc sine and sine inverse are just two different notations that mean the same thing. So like, sure. So just to reiterate this, like you remember how we talked about the square root of x and x to 1/2 really are two different notations that mean the same thing. The same idea here with sine inverse and then arc sine are just two different notations that mean the same thing. So on any problem like in number 1 where you're not given a range of values to find an answer between, You're using that. So for all of the problems on number 1, you'd use that to kind of determine your answer. Now, some of the time, the answer from your unit circle is not going to fall inside of that range, but you'll be able to find something coterminal to that angle that would fall inside of that range. So let's take a look at a situation where that might happen. Sound good? Matt? Yeah, the unit circle. You have to pick the one that falls inside of the range from negative pi over 2 to positive pi over 2. That's the range for that function. We covered that in the notes. That's always the range for that function. Yeah, that's why we wrote them down on the side, because I was going to use that information to do all the problems. Is that okay, Matt? Okay. Let's do another one of these. Let's say, for example, we'll do B. Sound good? Okay. So, I'm going to, tangent is what on the unit circle? It is y over x. So if I want to find a place where y over x is equal to negative 1, what I'm looking for is a place where y is equal to negative x, or negative x is equal to y, right? Where the coordinates have the same value but opposite sign. So if I look at my unit circle for a place like that, I see 2 places that fit that. Take a moment, look at your unit circle and see if you can find them. I see 3 pi over 4, and I see 7 pi over 4. At 3 pi over 4, the x-coordinate is negative square root 2 over 2, and the y-coordinate is positive square root 2 over 2. If I take y and divide it by x, I get negative 1, because they're the exact same fractions, except the only difference is the sign is for one is negative and the other is positive. Do we see that? The same is true at 7 pi over 4, where the coordinate is square root 2 over 2, comma, negative square root 2 over 2. The same thing there. If I take y and divide it by x, I get negative 1. Do we see that? Okay. If I look at these values, though, neither one of these is inside the desired range, right? 3/4 is bigger than a half, and 1 3/4 is bigger than a half. Do you guys see that? Everybody can see that? So what am I going to do? There should be an answer to this. I'm going to find an angle that's coterminal to either of these and see if that one fits inside of the range. Should I be looking for a bigger angle or a smaller angle in this case? Smaller, because both of 3 pi over 4 and 7 pi over 4 were too big, right? That's what we said. They were out past pi over 2. So if I want to find a coterminal angle that's smaller, should I be adding 2 pi or subtracting 2 pi? Subtracting. So if I subtract 2 pi from 3 pi over 4, I get negative 5 pi over 4. And if I subtract 2 pi from 7 pi over 4, I get negative pi over 4. Do either one of those fit inside of the range? That one does, right?
So did you
So if you're finding an angle that's coterminal, you're always adding or subtracting 2 pi.
Oh,
That's the definition of coterminal, is that they have to share the same terminal, the angles share the same terminal side, which means you just go another full rotation around from wherever you're at. Matt?
So, I guess I'm very like negative one right here. This is a 1 and 2 and that's like minus 5. I don't know why.
So we're not at negative 1. Y over x is negative 1. So the 2 locations where that happens is here. Neither one of those fit inside of the range for tangent. Well, 3 pi over 4 is bigger than pi over 2. And 7 pi over 4 is also bigger than pi over 2. So if this is like negative pi over 2 here, and this is positive pi over 2 here, both of those values are over here somewhere. They're not in between, right? Think about it just as fractions. This is 3/4, this is 7/4, that's a half. Both of those are too big. Right? If you just forget about the pi's and think about them as fractions. Well, in the case of tangent, it has to be strictly smaller because there are parentheses there. So to find something that will fit in that range, we're going to find an angle that's coterminal to one of those two. In fact, we'll find an angle coterminal to both of them. So that's why I'm subtracting the 2 pi, because I know that if I add or subtract 2 pi from an angle, I'm just going to get another angle that's at the same location, has the same terminal side. But the angle measure could be bigger or smaller, and maybe that one will fit inside of our range. Now, in this case, both 3 pi over 4 and 7 pi over 4 were too big, so I know that to find my coterminal angle, I should be looking for something smaller. That's why I subtracted 2 pi rather than adding 2 pi. And when I get that, I get these two answers. So negative 5 pi over 2 is over there somewhere, but negative, a pi over 4 is in there. So it fits. That's the one we want. Yep, that's our answer. What I'm trying to do is to explain to you what we're doing. So I want it to be really explicit, write everything down and show you how I'm doing things and how I'm making my decision, rather than just being I know it has to be in this quadrant, but that's not the right size, so I have to do, it just seemed easier. Negative 1 over 4, yes. Or you could just make a common denominator like you're in elementary school and subtract fractions that way, which you know how to do. In fairness. Kendall. Absolutely.
okay. So is the reason that you looked in those two quadrants because one of the x's or y's is the negative one be positive for a
Well, even in general, I know that if y over x is a negative number, either y or x has to be negative, but not both, right? Because negative divided by negative is positive. Positive divided by positive is positive, so I know it can't be in those two quadrants.
So are tan and sine, and I'm looking at the bottom here, are they not worth y over x, but a negative one of the x and x is negative or
I mean, the ranges for the answers are in the same two quadrants, yes. That is true. And that's what you're seeing there on the picture at the bottom of the unit circle. Vinny? Yes. Yeah. Yeah, that's exactly the idea. To find an angle that's coterminal? Yes. I subtracted because these guys that I found were too big. So I knew I shouldn't be adding. I don't need to make them bigger. I need to make them smaller. Not on this page. Do we feel okay on this one? You want to talk about some more of these? I'm happy to do more. You just got to tell me what you want me to do. What letter was that? G? Okay. I'm going to erase all this stuff. Is everybody okay with me erasing? I kind of used up all my space there. Nothing. Well, it's not the first time you've seen like two different notations to do the same thing in math, right? Right? Like we've used the dot for multiplication and the x. You've done division and you've done a fraction. They're all kind of the same thing. Yeah, basically. All right. So, what I'm looking for on G, again, because it's tangent, I'm looking for a place where y over x gives me negative square root 3 over 3. Right? So I'm going to go to my unit circle and look for a place where that happens. Now, at first glance, we don't see anything, right? What part of the negative square root 3 over 3 part do you think is the most interesting to me? Or the most helpful in figuring out where I want to be at? Yeah, the square root of 3 part. So I'm going to be focusing on ordered pairs where either the x or the y has a square root of 3 in it, or a negative square root of 3 in it. So, for example, 2 pi over 3 and 5 pi over 6 are both places that I would be interested in, because they both have square root 3 in them, right? One is the point negative 1/2 and then square root 3 over 2. And the other has the point negative square root 3 over 2, 1/2. So what I'm going to do is I'm going to do the y over x for each of those. Yeah, there's a bunch. Well, I know, again, since it's negative, one has to be positive, one has to be negative. So I'm just starting in one place, Kendall. You could. I just haven't got there yet. I'm just starting in that second quadrant. Okay? Well, it's not going to give you the exact value or whatever. And it probably won't even give you the answer formatted in the way that you'd expect it. But yes, you can type these into your calculator. All right. So if I am looking at 2 pi over 3, if I do y over x, that's square root 3 over 2 over negative 1/2. To divide fractions, I multiply by the reciprocal. And that gives me negative square root 3. That's not what I want, right? Okay? So then I'll try the 5 pi over 6. That's 1/2 over negative square root 3 over 2. That's going to give me 1/2 times negative 2 over square root 3, which is negative 1 over the square root of 3. That's not exactly what I'm looking for either, right? Squint at it a little harder, though. Yeah, we don't like to have a square root sign on the bottom, right? How do we fix that? Yeah, we multiply both the top and bottom by the square root of 3. So this is one of the spots we're interested in. Now, as Kendall pointed out earlier, the fourth quadrant is also going to contain a spot that we're interested in. The spot that we want is the one where the y-coordinate is plus or minus 1/2, and the x-coordinate is either the opposite sign, but square root 3/2. So if I look at that, where is that at? 11 pi over 6. Okay, so if we look at these now and compare them to the range, they're both too big, right? 5/6 and 11/6 are both bigger than 1/2. So what is our trick to deal with that? We subtract 2 pi. So this one would become negative 7 pi over 6. And this one would become negative pi over 6. Well, I'm subtracting 12 over 6 because I made a common denominator. Right? So if I'm doing 11 over 6 minus 2, I have to make a common denominator. Right? So that's how I got that. Of those two answers, is negative 7 pi over 6 inside the range we're looking for? No, it's too small, right? Negative 1 1/6 is less than negative 1/2. Is negative pi over 6 inside the range we're looking for? Yes, right? That's bigger than negative 1/2 and smaller than positive 1/2. Again, if you're unsure if the fractions are bigger or smaller, what's the easiest way to check? Look at the decimal, right? If you compare the decimal for 1/6 and the decimal for 1/2, 1/6 is 1.6 repeating, which is definitely bigger, or negative 1/6 is negative 1.6 repeating, which is definitely bigger than negative 0.5, right? Now, the alternative way of thinking about this it's a little bit more visual and a little bit harder for me to write things down, but just doing the same thing. If I think about All Silly Turtles Crawl, I know tangent is negative in the second and fourth quadrants. I know that the range for tangent is in quadrants 1 and 4. So the answer that I'm looking for is this one in here. I can go to my unit circle and do the same thing that we just wrote down and see that that spot is 11 pi over 6. Which is definitely too big, so I need to be thinking about going that direction. Or that direction is too big, excuse me. What I want is that direction, which is the negative. That's the range for tangent inverse, right? It's on the picture at the bottom. That's why the part of the unit circle is colored in. That's where the range is. You see on the bottom of your unit circle sheet the picture that's shaded? That's what that's illustrating. So that's a little bit less for me to write down. That's why I didn't do that or think of these problems this way initially. But it's perfectly fine to do them that way. There's nothing wrong with that. You're doing the same thing. You're just not writing anything down. It's a little bit more visual. But if that works for you, that's fine. It's a very visual subject matter in a lot of regard. So if that helps, you're certainly welcome to think about things that way. Are we ready to move on to the next kind of problem? Again, if you're still having some trouble, you can always come visit me during community time or whatever, and I'm more than happy to, go through some more stuff with you. Okay? Question 2. What do I have to do for these? Yeah, these are basically, should be almost impossible to get wrong. Good job, Matt. I think you might be able to do better than that.
Yeah, I should have got 43.
All right.
We just do edit.
Yeah. Guess how we do this? You just plug in your calculator. You do need to make sure it's in radian mode because the directions are asking for an answer in radians. So I'll turn my calculator to radians. So then I'll do sine inverse of 0.43. Then I write down that number and I'm done. What's the only problem on this list that we have to be a little bit careful about? D. Why? It's in degrees. So what are my options? Yeah, I can take this and convert it into radians by multiplying it by pi over 180. Or I could put my calculator in degrees, compute the answer, and then multiply the answer by pi over 180. Either way of doing it is fine. Questions about any more on question 2? Okay. Those should have been pretty easy, right? Yeah. How about question 3? Okay. Should we work from the inside out or from the outside in? Inside out. So, if I'm looking at A, I'm starting by looking at the arc cosine of a half. I know cosine is positive in this quadrant and this quadrant. And the fundamental range for cosine are these two quadrants. So the answer I'm looking for is in quadrant 1. Everybody okay with that idea? So I'm going to go to my unit circle and look for the place where cosine is equal to 1/2. That's the location where the x-coordinate is 1. So that's pi over 3. So this thing then becomes sine of pi over 3. And if I go to my unit circle and I take the sine of pi over 3, I find pi over 3 on my unit circle and then the y coordinate. So that's just root 3 over 2. And I'm done. Sure. You want to take a minute to do C, and then we'll do it together. That's fine. So again, I encourage you to try to do C, apparently. I don't know why we picked C, but okay. And we'll... Yeah, that's supposed to be an error. So it's like undefined. What's the domain for cosine inverse? It's on your sheet. Yeah, so if you look at doing cosine inverse of 1.83, can you do that? No, it's too big, right? Yeah, that's okay. If it's not in the domain, we can't do it. Okay. So, first thing I'm going to do is start from the inside. So I'm going to evaluate sine inverse of negative pi over 3. So since it's a negative value, I'm going to go clockwise from the x-axis. And if I go negative a third, that puts me here at 5 pi over 3. Right? Because I've gone 1/3 of a pi in that direction. Everybody okay with that idea? Okay. So sine is the y coordinate there, which is negative square root 3 over 2. So that gives me cosine inverse of negative square root 3 over 2. Now, I know that cosine is negative in the second and third quadrant. And the fundamental range for cosine inverse is in the first and second quadrants. So the answer I'm looking for is over here in quadrant 3, or in quadrant 2, excuse me. So I'm going to go to my unit circle and look for the place in quadrant 2 where the x-coordinate is negative square root 3 over 2. And that's 5 pi over 6. Matt, are you okay with that? So if you went back to the very first page where I wrote down the ranges for the 3 inverse functions, the range for cosine is from 0 to pi. So that's the first 2 quadrants. It's also on the unit circle on the back page of your review at the very bottom. It has that information on it as well. Okay? Do we feel okay on these ones? Okay. I'll do as much as you guys want. You just got to let me know what you want me to do. Sure. Yeah. Uh-huh. Go look at your unit circle. Yep, go look at your unit circle for a second, Kendall. Find cosine inverse, and look at what the domain is listed for cosine inverse on that sheet at the bottom. Okay? -1 to 1. What value are you trying to take the cosine inverse of in D? I don't know. What was it? Oh, okay. So you're getting an error because you're trying to do sine inverse of degrees in radian mode. You will get an answer if it's in degree mode. You need to check it one more time for me. No, you wouldn't. What's the news? I don't believe you. So, I'm going to change this to degree mode by pressing enter. Then I'll move out. Sine inverse 37.5. Enter. Oh, sure. Yeah, it's supposed to be an error. I'm sorry. I made a mistake. Okay. So let's talk about this one. Why is this giving us an error? What do you take? So if we have one of these inverse trig functions, these are mapping from what to what? So this is a mapping that sends some kind of things to some other things, right? So we have a ratio of side lengths. And we get back an angle measure. The regular trig functions like sine, cosine, tangent, etc. take an angle measure and give back a ratio of side lengths. Right? Look at what we're doing here. We're taking sine inverse of an angle measure. What's supposed to be the input for an inverse function? Yeah, that's why you're getting an error there. It's because you're trying to do sine inverse on the wrong kind of thing. Does that feel better? My apologies for not getting what you're saying to me. Does that help, though, a little bit?
Yeah.
Okay.
So, you pretty much call it
Yeah. Yeah.
right down what you know.
Yeah. Yeah. Okay. So you said you wanted to do one more of these. Which one were you guys doing? D? Okay. All right. Do you need a minute to try it? Sure. Take a minute. Work from the inside out. So first thing you'd want to do is figure out what the angle is for cosine inverse of negative square root 3 over 2. Once you find that angle, then you just take the tangent of it. Okay? So I got negative square root 3 over 3. Negative square root 3 over 3. So I started by trying to find the cosine inverse of negative square root 3 over 2. I know cosine is negative in the second and third quadrants. And I know the range for cosine inverse is the first and second quadrants. So my answer that I'm looking for lies in quadrant 2. So I went to quadrant 2 on my unit circle and found the angle where the x-coordinate is negative square root 3 over 2. That happens at the angle 5 pi over 6. Everybody okay with how I got to there? Okay. So then I took the tangent of 5 pi over 6. Tangent is y over x. So the y-coordinate at 5 pi over 6 is 1/2. And the x-coordinate is negative square root 3 over 2. To divide fractions, I multiplied by the reciprocal. So that's 1/2 times negative 2 over the square root of 3. When I multiplied, the 2's canceled, and I'm left with negative 1 over the square root of 3. And then I rationalize my denominator because we don't like to leave an answer with a square root in the denominator, leaving me with negative square root 3 over 3. Kendall, you don't have to apologize.
So I put in, I said it's like the 1/2 over 132 in my calculator, and I got negative.
Well, so try doing it this way. So press the alpha button and then the y equals button, and choose this numerator over denominator option.
Yeah, I did that.
And you did 1/2 over negative square root 3, and then make sure you moved over so you're outside of the radical, over 2. So that's negative 1 or negative 0.57 yada yada yada. If I look at 1 over the square root of 3, oops, I guess I should have made it negative, but it doesn't really matter, right? That's exactly what we have. Do you want to show me what you typed in your calculator, Kendall? Is that
I have the same thing, but isn't that negative?
I have a negative in my answer, right there.
No, like after you divided them, like the first step is all like
Here?
You have a positive after.
I have 1/2 times negative 2 over the square root of 3. Doesn't matter what part you make negative in the fraction, whether you want to make the numerator negative or the denominator negative. But if I went on the unit circle, the x-coordinate was the negative part and the y-coordinate was the positive part. No?
I'll show you later.
Okay. I'm not sure. I'm not positive what you're asking either, so I think there's some communication breakdown on both ends. But yeah, I'd be happy to take a look at what's going on and go over it again with you. Okay? Are we good with these set of problems, Matt? That doesn't matter because you're not doing the inverse of it. You're just doing tangent of 3 pi over 4. Yeah, so you're just going to get a negative answer or whatever, and then you do the inverse of it. You know what I mean? Okay. All right. Let's go on to question 4 then. I think these tend to be, or have been the hardest ones for you guys. Are these kinds of ones from question 4? Which ones would you like to do? Okay. So I'm going to start by doing two things. I'm going to first identify where sine is positive, because that's what we're getting here. So sine is positive in quadrants 1 and 2. And then I'm going to look at where this range is. So we're going from 0, and then we get to pi over 2. So that's the start of the range. And then we're at pi, and we're at 3 pi over 2. That's the end of our range. So the range of answers that we're looking for is between, or is in the second and third quadrants. So the angle I'm interested in is this one here. Is everybody okay with that reasoning? I'm sorry, what? We do not know which, we don't know what it is yet. Yeah. So sine of 0.31 is not a value on my unit circle. So I'm going to have to go to my calculator to get that. So I'll do sine inverse of 0.31. Better double check them in radian mode before I press enter. I am. Okay. So I do that, and I get this angle. This angle that the calculator is giving me is going to be that spot right there. And I'm going to call this 315 so it's not confused at where it came from. So the angle that the calculator gave me was this one. It's always giving me the angle between the terminal side and the x-axis. Okay? That's not the number for my answer, but I'm going to use that number to get my answer. What's that? So we're talking about two different things. So yes, if you're talking about an angle like a standard position angle, what I'm telling you though for this problem is you don't want to think about it as that. What the calculator is giving you is the angle between the terminal side of our answer and the x-axis. That's what that number is giving us, regardless of the sign of it. So whether the calculator has given me a positive or negative, I don't care. Just the positive is all I care about. I don't care what the standard position where it's at. I don't care about that. What it's telling me is the angle between the terminal side of my answer and the x-axis. All I need to do now is to figure out what that answer is. So in a case like this, where to draw the angle to my answer, I have not yet passed the x-axis. You see that? If I'm drawing this to my answer, I don't pass the x-axis, right? Okay? And maybe I should say, now let me rephrase. This is a better way of saying it. If the cloak if the shortest distance to the x-axis is like forward, you see how that's the case here, where the shortest distance to the x-axis would be going forward, I'm going to subtract. If the shortest distance to the x-axis is backwards, we're going to add. I would say sometimes that, and I'll show you an example of why in just a moment. That's what my calculator gave me when I did sine inverse of 0.31. It's because you were talking to Hannah while you were doing that. So that's what after I figured out where my answer was, I went and computed the sine inverse. Because you're in degree mode. So on this one, this next spot on the x-axis is pi, and I'm going to be subtracting that 0.315 to get my answer. Well, that's the next spot on the x-axis that I would get to, right?
Yeah.
Madison?
Would it be safe to say that if you're in the first quadrant, then your angle is like
That the inverse is going to give you the angle that you're looking for?
yeah.
Not necessarily. And the reason I would say is maybe you have a situation where it's like, where you've gone, where the range of values is bigger than 2 pi.
So then you just like subtracted it, like get the range first, within the range within the unit circle, and then just added that one at the end.
Yes, you can think about it that way as well. That's fine. That's not the way I like to think about it, but yeah, there's nothing wrong with doing it that way. So this brings up another point that Madison points out, is another way you can think about this problem. Can I start this over doing it what Madison has suggested? Okay. Which is, again, perfectly valid way of approaching this problem, is Madison says, what if I start by just changing this so that it is the fundamental range for sine? So what would I need to subtract from both sides of this inequality to turn it into the range for sine? Well, remember the range for sine that we're looking for is negative pi over 2 to positive pi over 2. So if I subtract pi from both sides of this, I would get exactly that, right? So now, if I take sine inverse of 0.31, I'm going to get about 0.315 from my calculator. And then, Madison, what are you suggesting we do now with this? So if I
Subtract that angle from pi.
yeah, so again, we know that, why are we subtracting that from pi? I know it works, but how would I know whether I add or subtract here?
Well, like, I did it to my friend for help,
Mhm.
and she drew up this chart that was really helpful.
What's the chart look like? What is this symbol here? Oh, that's just like an alpha or something, right? Okay. I think these are reversed, though.
Oh, yeah, but I wrote it.
All right. So Madison says that I can do it this way, and I think this is correct. This seems like this will work every time. So to review what we did is we started by taking the given range and turning it into the fundamental range for sine or cosine or whatever. Is this right, what I've written down, Madison?
Like, I wouldn't even turn it into like the range course sign. I would just make sure that I could see it clearly on the unit.
Okay.
I don't know, it works like just to write it into it.
Yeah, no, I understand what you're doing, and I acknowledge that it's going to work. I'm just trying to systematize this a little bit more. Because this value here, oops. Okay. Yeah. Okay. So there's that, and if I do then, I know my answer is in this quadrant using the same technique that we did before, where I know sine is positive up here, and my answer is looking for right there. No? It's just a variable symbol. It's Kendall, it's the Greek letter alpha. We're just using it as a variable. It's telling us when we add or subtract.
So would that mean like we subtract pi from 0.315?
Yes. Except the other way around. Pi minus 0.315.
So then like, if it wasn't with like the fourth quadrant, would it be 2 pi minus 0.315? Like that symbol is just the answer in place of it?
Basically, yes. Yeah.
So that's a 2.83.
That sounds about right. You know how to check it, though? So if I do sine of 2.83, which is what you said your answer was, what should I get back from this? 0.31. So close enough. There's going to be a little bit off because you rounded. The other part of the check, though, this is the second thing we need to check, is we have to make sure 2.83 is between pi over 2 and 3 pi over 2. So pi over 2 as a decimal is 1.57, definitely bigger than that. And then 3 pi over 2 as a decimal is 4.7, definitely smaller than that, so we should be sure that that's our correct answer. What do you want to look at next? Okay, which one? Okay. Standing in the street in the middle of Chicago, you look up at a building and the angle of elevation to the top of the building is 43 degrees. So here's our line of sight. The angle of elevation is measured from the line of sight to the terminal side of our angle. 200 feet closer to the building, you look up and the angle of elevation is now 58 degrees. Find the height of the building. So what I'm going to do is I'm going to call this side X. That makes this piece 200 plus X. That's going to give me the triangle 43, 200 plus X, and H. And the other triangle, X, H, with 58 degrees. So here I can say tan 43 is going to equal opposite over adjacent. And here I can say tan 58 is going to equal opposite over adjacent. And now I'm going to solve this system with substitution. So I'm going to get this h by itself. And I'm going to get this h by itself. And since they're both equal to h, I can set them equal to each other. Now to solve for x, I'm going to get the x's on the same side, so I'm going to distribute that tan 43. And then I'm going to subtract that x tan 43 to the other side. I can factor an x off. And then I can divide both sides by tan 58 minus tan 43. And when I type that into my calculator, I'll get an answer for x. And then I can use that answer to solve for y. When I do this, though, I got to be careful because I have to make sure I'm in the correct mode. What mode should I be in? Degrees, because if I remember, these angles were measured in degrees. Stop talking, guys. So that gives me 279.27 for x. And then if I go back to either of these two equations, I can plug x in and get my value for h. So, for example, h is x times tan 58. So if I take this and multiply by tan 58, I get my answer there, 446.95.